Hi again and welcome to part 3 to this video challenge exercise. You may recall from part 2 what we worked out was the gradient between f and g up here, and that gradient was a negative gradient going out that way if you recall, and what we have is a negative 3/4. Now what we asked to do is to prove in this part, our objective, to establish and prove that this line here, EF, FE, is actually perpendicular to the line GF. So we want to prove that this is at right angles, 90 degrees here. So what do we do that? Well, we have already from part 2, as I indicated earlier, the gradient negative 3/4. So all we need to do is work out what the gradient is here for FE, and then we could put it into the negative reciprocal to confirm whether or not it is perpendicular. So let's do that now. One of the first things we've got to have a look at is the gradient formula. You already know about that. So what I'm going to do is work out the gradient between E and F. So you know what I always do now? I like to label up so we don't make any substitutions errors. So I'm going to put up here x1, y1. So here's our x1, y1 and our x2, y2. There we go for the 2 points. Now let's drag and drop them right over here so we can establish the gradient between E and F. Let's do that now. So y2 minus y1, x2 minus x1, rise over run. Let's sub in there. So our gradient M is equal to y2 minus y1. Where's our y2? Down here, that's a 0. Minus, where's our y1? It's up here, that's a 4. So there's our 4. x2 minus x1, 5 minus 8. So that's 5 minus 8. So our gradient for FE, which is the same as EF, is a negative 4. All over 5 minus 8 is going to yield a negative number. So we're going to have here negative 3. Now we can cancel the two negatives and make them positive. So that's a positive there, positive there. So our gradient essentially is for FE 4 over 3. So FE 4 over 3, let me write it in here, 4 over 3. Now is that perpendicular? Well, it looks perpendicular because this is the negative reciprocal of that. What does that mean again? Negative reciprocals is if you have a gradient, you turn it upside down and change the sign. That's a negative reciprocal. In other words, M1 equals 1 over M2 negative. So that does look like they are perpendicular, and I'm also going to confirm it by doing the other formula, which is when we have M1 times M2 should equal negative 1 if they are perpendicular. So there's another way to further enhance our answer. So M1 for us, let's call it 4 over 3, times, where's our M2? Our M2 is negative 3/4. Let's multiply them. So we have 4 times a negative 3 is negative 12. All over 3 4s are positive 12. Now we have a negative 12 over a positive 12. That's going to yield a negative number, and let's hope it's a negative 1. So yes, it does look like it's a negative 1. So in fact, yes, these two lines are perpendicular at 90 degrees to each other.